all. Today we are going to discuss the first class quiz, which was regarding the equipment basics, pump and compressors. In the first lesson, we discussed their operations, their operational problems, and how to resolve them. So let's see what we have learned, and it will just take 5 or 6 minutes to complete this quiz. The first question is related to which statement is the correct for pump and compressors? Let's see. Pumps are used to transfer gas and compressors the liquid. So as we just discussed, and it's a basic question about the difference between pump and compressors, pumps are used to transfer the liquid or pressurize the liquids, and the compressors are used to transfer and pressurize the gases. Therefore, this question, the A variant, is not correct. Let's see the B one. Compressors change the kinetic energy into hydraulic, and pumps change from potential to electrical energy. So compressors use kinetic energy and change it to potential energy, PE, and whilst the pumps change from the electrical energy into hydraulic energy. This one is also not correct. If pump is working at minimum flow, it's called surge, while maximum flow called choke or stonewall condition. So this is also not correct because the pump minimum flow condition, we don't have such condition which is called surge, or maximum flow condition called stonewall or choke. This is correct for compressor operations. The last one is PD pumps are better for viscous applications. Yes, that's correct, and that's why we'll go with the last variant. So let's go to the next question. Next question is about what are two main types of compressors. So for both pump and compressors, which are regarding the fluid transportation equipment, they are mainly divided into two sections, which is positive displacement, and the second one is about the dynamic pumps. So we'll go with this one. The screw, reciprocating, or rotary, they are subsections of the dynamic and PD pumps. Next question. Combine the correct order in compressors: adiabatic, isentropic, isothermal, and polytropic. And we have two question sets. The minimum work and maximum work is done in the compressors. It's more about the thermodynamical question in compressors. We just discussed in the last lesson that the most work, the maximum amount of the work, is completed in adiabatic one, and the minimum work is completed in isothermal. So let's see the graph together. As you know, here we are processing the different types of compression process in compressor thermodynamics. So if it's like the PV diagram, and we know that the W work is equal to PV multiplication, and as the volume is changing, also the P values, the pressure values, are changing. Let's see the graph itself. From B to C, the red curve, it will be the representative of the polytropic process. B to C dash, just one dash, the blue one, it will be about the adiabatic, and B to C double dashes, which is the green curve, it will be isothermal process. If we look through the area between PV diagram, it will be the minimum, and for the adiabatic one, it will be the maximum area. That's why we say that the maximum work is done on the adiabatic. On the other side, the minimum work in the isothermal process. Next question. Fill the gaps. Okay, it's a condition that occurs in compressors. So the keyword is compressors, which is a condition. Amount of gas they are trying to compress is insufficient. Okay, we have already two keywords. One of them is compressors, and the second one is the compressors, they are insufficient. In terms of what? For the size of compressor and blades lose their ability to transfer energy from shaft to fluid, okay, as the insufficient in terms of flow most probably, and causing a reverse flow of the gas. So this is a compressor, they have the insufficient flow, they lose the energy to transfer energy from shaft to fluid. It's one of the most important problems that we are commonly facing in the industry, which is a surge condition. Surge. So this is the minimum flow cases. Which one or one's not correct to avoid cavitation? So operate with lower suction pressure. then decrease vertical separation, minimize bends and fittings, and select larger diameter. So to understand this, let's see first of all what cavitation brings to us. So it will lead to like erosion of the impeller blades within the pump itself. So the general day, in order to avoid the cavitation, we have very important formula, which is the NPSH available must be greater than NPSH required. So the NPSH required is provided by the pump manufacturers, and whereas the NPSH available is found out by the engineers, operational engineers. So the NPSH available, if we are looking into the formula itself, we have the PSV, which is suction pressure, so plus H, total suction head, PF, frictional losses, and PV is the vapor pressure. So it means that in order to avoid the cavitation region, we need higher NPSH available. It means our suction pressure must be higher, our total suction head must be higher, whereas the PF and PV, vapor pressure, and friction losses must be lower. So let's see, operate with lower suction pressure. It's not correct, because if we are operating with lower suction pressure, it means that NPSH available will be lower. Therefore, will be more closer to a cavitation region. The first one is correct. Next, vertical separation, decrease vertical separation between liquid level and the pump. As we are getting the higher H, the total suction head, it means NPSH available will be higher. In our case, the question says that. So vertical separation must be lower, NPSH available will be lower. So that's not correct to avoid cavitation. That's why we are also taking this. Next one, minimize bends and fittings. So as we know, bends and fittings are very important for the pump operation because they will bring some frictional losses, right? PF itself. So the PF is minimizing bends and fittings, but there is a keyword, discharge of the pump. Okay, so we are mainly interested in the NPSH acronym is standing for net positive suction head, the suction head, right? Therefore, in order to get, let's say, not to be in the cavitation region, we need to get higher NPSH, and we are mainly interested in the suction of the pump, not the discharge of the pump. Therefore, it's not also correct because we are not interested in, and it's not correct to avoid cavitation. We are also choosing this. Select larger diameter at the pump suction. So if we get the D is higher, greater D, it means the PF will be lower, right? From the formula itself. If the PF is lower, as it's a minus, it will be minus and minus together, it will be higher. Therefore, the higher this one, higher the NPSH available. So it means that it will help us to be like the not closer to a cavitation region. That's not correct. So 1, 2, and the 3, they are all correct. Just discussed in the last lesson that so the check valve is used to prevent backflow scenario in pump operations. The answer is check valve. So for this lesson, we are completing the quiz questions, and in the next lesson, we'll mainly be discussing the refinery processes and then distillation column. Thank you. Goodbye.